The ESP32 series is really great. It's fast, lots of memory, Wi-Fi, Bluetooth, USB, and it is not expensive. However, there's one thing which is not so great. If you check the documentation, you will find that the ADC, the analog to digital converter, seems really poor. Did the engineers at Espressif just forget about the ADC? Well, they did not. In fact, they provided a built-in calibration solution. Each ESP32 chip has factory calibration data stored inside its eFuse memory. And I found out it is very easy to use it. In this video, I will show you how to use this method. It requires no extra components and no extra code. I will show you how it works and verify the results with an ESP32 Classic and an ESP32 S2 Mini. Let me explain the problem with AnalogRead first. In the Arduino IDE, we normally use AnalogRead to read a value from an analog input. This also works for an ESP32, which has a very good 12-bit resolution. The S2 even has 13 bits. The ESP32 uses an internal voltage reference of 1100 millivolts. And if you want to measure higher voltages, you can use the built-in attenuator to reduce the sensitivity up to 11 dB, as we do here. This is about 3.55 times. AnalogRead will then return a raw digital 12-bit value of 0 to 1495, and we can transfer this to millivolts by this formula. We take the 1100 millivolts reference, divide that by the 12 bits and multiply that with the attenuation. But there is a problem. The 1100 millivolts reference can have a big deviation of almost 10%. Then there is the attenuation. It is also not very accurate because of resistor matching in the chip, gain errors and non-linearities. As a result, AnalogRead is very inaccurate, as you see in this curve that I measured. The yellow dotted line is the curve that we expect. The red dotted line is the reality. Now you can add some code and components to calibrate the curve, but there is no need for that because Espressif already did that during the manufacturing. They measured the deviation and saved the calibration factors on the chip. Now, how can we access those calibration values? Well, that is easier than you think. If you replace AnalogRead with AnalogReadMilliVolts, the compiler will automatically use the calibration factors and you get an accurate reading. So no additional code is needed and you get millivolts directly without any formulas. I tested this for a classic ESP32 and for a newer ESP32 S2. To test it, I used the following circuit. I use a linear power supply of 0 to 40 volts and the resistor divider, as you see in the schematic, to get a voltage of about 0 to 4 volts. I added this 10-turn trim potentiometer so I can adjust to exact voltage values. On the output, I added a capacitor to filter out any noise. Then I measure the voltage at the ADC input with a Victor 87E. Then I have the ESP32s connected with their ADCs running an Arduino code which sends the non-calibrated and calibrated values to the serial monitor. And in this table you see all the test results. Here are the results in a graph. The horizontal axis is the actual input. The vertical axis is the ADC result. The dotted lines here are the non-calibrated values from AnalogRead. So if I apply 2000 millivolts to the AnalogRead, my ESP32 Classic will report about 2200 millivolts. The ESP32 S2 reports about 3000 millivolts, so that's a really big deviation. The solid lines are after calibration. You see that they are very close to the ideal line, which is the yellow dotted line. At higher voltages, the ESP32 S2 cuts off at about 2600 millivolts. The ESP32 Classic cuts off above 3000 millivolts. So make sure not to use the ADC at too high voltages. I would stay clearly below 2500 millivolts. At low voltages, you see that the boards behave differently. Let me zoom in on the 500 millivolt range. The newer ESP32 S2 is clearly better than the old ESP32 Classic. It can even measure below 50 millivolts. Really good. The ESP32 Classic cannot detect voltages below 150 millivolts. This is known and you need to consider this if you want to use this chip. I recommend that you select the newer ESP32 S and C series. So if we use AnalogReadMilliVolts and make use of the factory calibration, the ESP32 ADC is actually pretty good. I hope you liked the video. If it was useful for you, please like and subscribe and leave your experiences in the comments.